Hi, this is Marc Roth, and this is Mathematics for Social Justice. Today's topic will be, is the Pythagorean theorem obvious? So the Pythagorean theorem may or may not be obvious, but it's not obvious that it's obvious. So let's review what the Pythagorean theorem says. If you have a right triangle and you build the square off each leg, and off the hypotenuse, if this side is A, the area is A squared. If this is B, the area is B squared. And if this is C, the area is C squared. So the Pythagorean theorem says the two smaller areas add up to the big area. In other words, A squared plus B squared equals C squared. So the question is it obvious? And it's not obvious to most people, but can we teach it in a way so that it becomes obvious to our students? And my claim is we probably can. Let's see how we might do that. Now, instead of working with 2 dimensions, let's go back to 1 dimension. So let's look at a circle. And its diameter. So suppose we pick a point on the diameter. Then we can find its midpoint and construct a circle. And find the midpoint of the other part of the diameter. Construct another circle. So a theorem would be the sum of this circumference plus this circumference is equal to this circumference. So the question is that obvious? And I think it's pretty obvious because you have, let's call this D1 and D2. So these are our 2 diameters, and the whole thing would be D3. We'll just call it D. So D equals D sub 1 plus D sub 2. All right, so then to get the circumference, you just times by pi. So pi times D sub 1 plus pi times D sub 2. By factoring, we get pi times D. Basically, we're just saying that since D1 plus D2 obviously adds up to D, if you times by pi, you get pi D, which is the big circumference, is equal to the 2 smaller circumferences. So it's pretty obvious that this circumference plus this circumference adds up to this circumference. Well, the Pythagorean theorem is almost as obvious, because if you have a circle, pick a point there, it's well known that a right triangle inscribed in a semicircle is a right triangle. It's also well known that if you drop down this perpendicular, that this triangle and the 2 triangles combined make up 3 similar triangles. Now, when you build these squares, it's the same basic idea that we did with the diameters. The 3 squares are all similar. The 3 triangles are all similar. In each case, we have a square built on the same part of each of these 3 similar triangles. So with the square based on this hypotenuse, the square built off this hypotenuse, and the square built off this hypotenuse, we've got similar figures in the same position. So before we had segment, segment, and segment, 3 similar segments, and then 3 similar circles. It's the same basic idea. So as a matter of fact, if you call this length h and this distance c, 2c over h will be the conversion factor. If you times this area by 2c over h, you get this. If you times this area by 2c over h, you get this. If you times the big area of the complete triangle by 2c over h, you get this. So instead of timesing by pi, we're timesing by 2c over h. So this is basically why the Pythagorean theorem is obvious to me. It's definitely not obvious to people unless you think about it this way. So it's not obvious to most people, but it is obvious, and I'm actually of the opinion that it should be taught. So going through a formal proof is nice, but people should understand why the Pythagorean theorem is true.